if you think about cloud systems, they have another dimension. Like there's this dimension of time that describes what the system is, what a single process is doing. But there's also this spatial aspect of like describing the architecture, the infrastructure, the connection between everything. And one of the realizations we had is that traditional programming languages, they're not good at describing these two dimensions, right? Like you can't really, because there are some fundamental assumptions that are that exist in existing languages that really makes it hard for us to model this concept of time and space in a way. And this a simple example is like if I'm writing some code that's expected to run inside a container, and that code needs to interact with something in the infrastructure side on the spatial dimension, then the compiler of the traditional language doesn't understand that these things actually need to cross over to another process, right? Like it doesn't have the ability to, because it assumes that everything is running inside a single memory space, right? Like it has all these assumptions. And in a sense, this is the only unique thing about Wing is this concept. We call this pre-flight and in-flight. Basically, it has these two dimensions where you can define the infrastructure and you can define the application code, and they can just naturally interact with each other. And the compiler understands this interaction and can derive the needed infrastructure configuration, the needed permissions, the needed networking configuration. It can derive those things by just understanding the relationship between those two dimensions.